Okay, so in this question, we said we have that points Q and R lie on a circle with center P. So here we have a circle with center P. Then Q and R lie on the circle, and the radius is 9 inches. So the radius of this 9 inches. Triangle PQR has a perimeter of 31. What's the length of QR in inches? So the QR lie on the circle. So we're talking about triangle PQR. So we are creating a triangle. So since Q lies on the circle and R lies on the circle, we can have something like this, right? And we're told that the radius is 9. So this side is 9. This side is 9. Then QR, what we're looking for is X. Say perimeter is 31, so basically 9 plus 9 plus X equal to 31. So X equal to 31 minus 18. So here X equal to 13. So that's option B, right? Then the next one says a cube has edge length of 68 inches. So this is a cube. Edge length is 68 inches. And a solid sphere with a radius, I think we've done something similar to this. A solid sphere with a radius of 34 inches. So radius of this sphere, solid sphere, is 34 inches. So you say a solid sphere with the radius of this is inside the cube. That means the cube is larger, right? The sphere is inside the cube, so that the sphere touches the center of each face of the cube. The nearest inch is what's the volume of space in the cube not taken up by the sphere. So basically, we want to calculate the volume of the cube, then subtract the volume of the sphere. So volume of cube is basically L cubed, which is 68 cubed, right? And this will give us 68 squared times 68. So we'll have 314432 cubic units, cubic inches. So for the sphere, volume of the sphere is 4/3 pi r cubed. This is 4/3 times 22/7 times 34 cubed. So here I'm going to have 88 divided by 21, then times 34 times 34 times 34. So I have 164702 approximately as the volume of this sphere. So I want to find the space in this cube that is not occupied by the sphere, so I'll just find the difference of their volumes. So I'll say this minus, just do the other way around. So this should give me about 149 7, yeah. So option A is the correct answer. Okay, next question. Since in a triangle ABC, the measure of angle B is 90 degrees, so we have a right angle triangle here, and this is B. So A and C can be anywhere in between. So BD is the altitude, is an altitude of the triangle. Okay. So the length of AB is 15, and the length of AC is 23 greater than the length of AB. So 23 greater than the length of AB, what's that going to give us? So 23 plus 15 plus 38, so this is 38. So they want us to find BC over BD. So they say BD is an altitude of the triangle. Let's find. So we're going to use Pythagoras theorem. I actually prefer this. Let's use Pythagoras theorem to quickly get BC. That's 38 squared minus 15 squared. So this gives us doesn't give us a whole number. I think it should. So this altitude d. So when you have any triangle, you can actually, especially when you have whenever you have a right angle triangle, you actually generate an altitude from that triangle apart from the height. So, and this is how to generate the altitude. It's going to be something like this. So this is how to generate an altitude from a right angle triangle. So you can actually bring out the two triangles so that you can see them clearly. So in the first case, you're going to have the normal one, which is A, B, C, and in the second case you're going to have 90 degrees, the other one, which is B, this is D here, BDC. So AC is 38, AB is 15. So what we want to find is BC over BD. So from here you can see that they are actually similar triangles, right? So BC over BD, that's the ratio we want to find, should be equal to what? So this is hypotenuse over, so basically you know that it's hypotenuse over the given side, right? The one of the legs. So this is going to be 38 over 15. So since they are not asking us to find a specific side, right? So BC is 38 over 15, which is option D. Right. So in the next question, this is a right circular cylinder with radius r and height h. Then we have a second one which is not shown and has a volume that is 302 times this. This volume represents the radius in terms of r. So basically you have the small and large cylinder. So for the small, the volume is simply pi r square h, while for the large, they say the volume is 302 times as large as the volume of the cylinder shown. So that means the volume for this is 392 pi r squared h. Right, in this case, h is the big H, and r is the capital R. So in the case that is the big. Sorry, so they want us to express the radius capital R in terms of small r and all of that. So how do we go about that? So first of all, by the time we compare, we'll see that pi cancels pi. Okay, so pi cancels pi. So let's start with the r. So by the time we compare this v and this volume, maybe by some ratio, so okay, so let's use the ratio approach. So whatever this volume is small v and this is capital V. So let's do small v over capital V. So that will mean pi r squared h over pi r squared h. So pi cancels pi. Now if small volume is 1, the big volume will be 1 over 2. So this will 1 over 392 basically. So so how do we relate the radius of the second cylinder? Let me see. I thought this will give us a faster. So let's use what I started with before. So this volume is simply pi r square h, and if it's 392 times, so this capital V will be 392 times of pi r squared h. So let's substitute this and see which one will give us that. So the basic control, so pi cancels pi, so the basic control that we want to see here is r squared and h should give us 392. So 8 with 8 squared times 7 will give us 392. That's 64 times 7, 448. So radius cannot be 8 while height is 7. So this is out. Radius cannot be 8 while this is definitely out as well. So Let's try 7 squared times 8. So that's 49 times 8. So that's 392. Yeah. So option C is our answer. Right. So you can get that by mere substitution. Okay, so we'll stop here in this video. We'll continue in the next one.